Hello, welcome back. So we're going to continue on with our review of AP questions. So this time we're going to be looking at the 2018. This is the differential equation from AV. Again, really good practice for us. So we're given this derivative dy dx, which is this 1/3 x times y minus 2 squared. We're given the slope field for this differential equation as well. And we want to sketch the solution curve that passes through the point 0, 2, and the solution curve that goes through 0, 1. So this is just graphing. We just want to take a look. If I'm at 2, if I kind of graph it, if I kind of notice, it kind of looks like it's just a horizontal tangent right there, so it may be an asymptotic function. And you would get 1 point for that. Graphing at 0, 1, 0. Here's right here. Now notice this one kind of goes up as we move to the right. And I'm going to kind of try to follow, whoop, messed up there, kind of follow the curve as much as I can. And if I go to the left, same thing. I'm going to go down. Eventually, it kind of looks like it's moving up. And looks like right over here. Just keeps going. And there's our graph. And you would probably get 1 point for that one as well. All right, so let's take a look. So for part B, now it asks us here, let y equal f of x be a solution to the differential equation. And they give us again the initial condition y1 equals 0, and we want to write the equation of the tangent line and use it to approximate f of 0.7. So for part B, we need a tangent line, so we need two things. One, we need a point, 1, 0, and the slope. The slope comes from our derivative at the condition 1, 0. I'm making it look all fancy, and I can come up here and do that. Remember, it's this 1/3 x, y minus 2 squared. So if let me scroll out of here real quickly here. There we go. Oh, that didn't help out too much. I'll just zoom back in here. There we go. So remember our derivative, it was this 1/3 x squared. So it's going to go 1/3 x, which is 1 squared. And then it said y minus 2, so y is 0, so 0 minus 2. Whoops, sorry, that wasn't squared. That should just be a 1 power there. This part was squared. And I can simplify that, and that is going to become, what's that, 4/3 right here. And so let's see here. So my tangent line will be y minus 0 equal to 4/3 x minus 1. And you'd probably get a point for that. But we're not done. We wanted to estimate the value at 0.7, so we would just now let x equal 0.7. Y equals 4/3. This is 0.7 minus 1. Leave it alone if you want to. Or y equals 4/3 times negative 0.03. Whatever that's going to be. Whoop, not negative 0.03. That's embarrassing. Negative 0.3. Let me erase all that evidence right there. And if you want to clean that out, that is just negative 1.2 over 3, and if you keep going, what's that? Negative 0.4 or something like that. You don't have to. You can stop here. You can stop here for all that matters. All right. Now the last part, this is the tricky part. Now they want us to solve it. Find the particulate. So now they want us to solve for y here. So I'm going to write out my derivative, dy dx. This is part C here. And that's going to equal this 1/3 x y minus 2 squared. Separate your variables. This one we have to separate the variables right here. And that's going to give me 1 over y minus 2 squared dy equals 1/3 x dx. You get 1 point for that. Solving the integral. Now this is not natural log, be careful. Now the right side is pretty easy. We just get, we're going to get x squared. We're going to divide it, so we get 1/6 x squared plus your constant of integration. But over here, this is not a natural log. This is just y minus 2 to the negative 2 dy. And if we do that, that just gives us, what's that? Add 1, negative 1, so negative 1 over y minus 2. I'm going to write that over here. Negative 1 over y minus 2 here. All right, so at this point, I'm now going to solve for C. I'm going to find C. Given the initial condition they gave us, 1, 0 again. and I'm just going to plug it in. If I plug it in, I'm going to get negative 1 over, let y be 0, negative 2 equals just 0 plus c1. So therefore, c1 is 1/2. And now I just got to solve for y. Negative 1 over y minus 2 equals 1 over 6x squared plus 1/2. Divide by the negative. All right, so I get negative, oops, sorry. Terrible there. So we would get 1 over y minus 2 equals negative 1/6x squared minus 1/2. All right, now I'm going to do some really fancy algebra right here, so see if you can follow along. I have two options. One, I can get a common denominator, which isn't so bad here. It's just going to be 6, and that's going to give me negative x squared minus 3. Very easy to do. So that's going to give me y minus 2, so I'm going to flip it now, 6 over negative x squared minus 3. And therefore, solving for y, we get 6 over negative x squared minus 3 plus 2. And there is your antiderivative. There is your solution curve. All right, now there's another way I could solve it. I'm going to solve it right here real quickly. Option 2. Okay. Once I have this 1 over y minus 2 equals this negative 1 over 6 x squared minus 1/2, imagine everything is over 1, and I just flip it. So now I just put everything over 1, and I can flip it. Y minus 2 equals 1 over all of this, 1 over 6 x squared minus 1/2, and then I can just add 2 to both sides, and I can clean this up if I wanted to, or you can just leave it alone. All right. Hope you enjoyed the video. I'll see you soon. Bye-bye.